Hi guys, it's Simply Statistics, and in today's video we are going to discuss the empirical rule and z-score and do a couple practice problems. So let's just jump right into it. We use the empirical rule when we have a set of data that is normally distributed. Now, provided that it is indeed normally distributed, the empirical rule tells us that almost all of the observed data will fall within 3 standard deviations of the mean. So here is the application of the empirical rule. It will always be with, again, a normal distribution, also referred to as a symmetrical curve or a bell-shaped curve. If you think of it as a symmetrical curve, this is easy to apply the concept of empirical rule because the mean will be right in the center and everything that you see on the right will be exactly mirrored on the left. So let's go through the rules. Empirical rule tells us that 68% of the data will fall within that first standard deviation. Now remember, it's symmetrical. Whatever appears on the right has to also appear on the left. So if within the first standard deviation I have 68% of the data, 68 divided by 2 is 34%. Now let's jump to the second standard deviation, in which we will see 95% of our data. How do I get 13.5 and 13.5? Well, I've already accumulated 68% of my data, and then I jump to 95% of my data. So that is a 27% difference in between 95 and 68%. So if the difference is 27%, and remember, whatever I mirror on the right side has to appear on the left side, I want to divide it by 2. Same thing, dividing 27 by 2 gives me a 13.5 on both the left and the right hand side. And cumulatively, that will equate to 95%, and you can test it out for yourself. 13.5 plus 34 plus 34 plus 13.5 does indeed give you 95%. Now we apply that same logic to get the last and final standard deviation, which is the third standard deviation from the mean. We will see 99.7% of our data. And same thing, we just find the difference, 99.7 and 95, and then we divide by 2, and we get 2.35 on the right and left hand side. Okay, now where do these little 0.15% come from? Well, remember, empirical rule only accounts for 99.7% of the data, or almost all of the observed data. So there's this remaining 0.3% that falls beyond the 3 standard deviations, and that 0.3% has to again be evenly split on both the right and the left hand side. So we divide by 2 and have a remaining 0.15% that is on the right and the left hand side beyond our 3 standard deviations. So let's do an example now that we have our application. So here we have 57 adult women had their heights taken in inches. The heights are normally distributed, so we may use the empirical rule. We have a mean of 63.49 and a standard deviation of 4.34 inches. We want to label the mean and the 3 standard deviations from the mean using our knowledge of the empirical rule. So mean goes in the center. Let's label 63.49. Now, how do I label the value that goes here on our first standard deviation to the right? I have to take my mean, 63.49, and add 4.34, which is my standard deviation, and that gives me a 67.83. So that is my first standard deviation to the right. I just added 4.34. Now I've got to add yet another 4.34, and that will give me 72.17. And for a third time, or for my third standard deviation, I will add another 4.34, and that gives me a 76.51. Now, if on the right-hand side I was adding, logically on the left-hand side I should be subtracting. So let's begin 63.49 rather, minus 4.34. That's going to give me my first standard deviation to the left as 59.15. Okay, and then similarly, we're just going to subtract another 4.34, and we get 54.81. And again, we subtract 4.34, giving us a 50.47. So these are all of my values for my 3 standard deviations from the mean, as well as my mean located in the center. So let's answer some questions. What percentage of women are between 59.15 and 67.83 inches tall? Well, this is super easy to answer because I've labeled my bell-shaped curve using the empirical rule. So I just have to find 59.15 and 63 or 67.83, and I see that these are the first 2 values, 1 standard deviation from the mean. 1 standard deviation to the right and 1 standard deviation to the left. And empirical rule tells me 68% of the data falls within that first standard deviation from the mean. So my first answer is 68%. What percentage of women are between 54.81 and 67.83 inches tall? So again, let's find 54.81 and 67.83. Now this one's a little different. Here, I move 1 standard deviation over to the right and then 2 standard deviations over to the left. So how do I find this? Well, I'm going 54 to 67.83. Think of it like I just want to add the percentages of everything that falls within this shaded region here, which is that 34, 34, and 13.5. And adding those up will give you 81.5%. Let's do the next one. What percentage of women are shorter than 63.49? So locating 63.49, I want to know how many or what percentage of the women are shorter, that's everything to the left of the mean. And if the mean is directly to the center, that means 50% of the data, exactly half of the data, will be to the left of the mean. And this one, what percentage of women are taller than 72.17 inches? I will locate 72.17, which is here, and I will again add those percentages, 2.35 and 0.15. So that is the empirical rule. Now, something I will note is that with the empirical rule, we can't necessarily answer questions about observed values that are not one of our labeled standard deviations. For example, if I were to ask you what percentage of women are taller than 60 inches, 60 inches is about here, but it's not perfectly 1 standard deviation from the mean. So you couldn't necessarily answer that question without having some extra knowledge. So in those scenarios, what we do if we can't rely on the empirical rule is we should instead rely on the z-score. So what is the z-score formula? I will remind you really quickly that it is x minus x bar divided by s, which is the mean divided by the standard deviation. And sometimes you might also see this formula written as such, but they both mean the same thing. It's your observed x value minus whatever your mean of your sample is divided by your standard deviation, okay? Now let's do a practice problem. So in this practice problem, I want to remind you before we dive in that z-score is again used for normal distributions, and it's a way for us to describe the distance of a data point from the mean of the distribution. So in this example, we're still using the information from the prior question, but I'm asking about the height of a woman who is 57.16 inches tall, and I'd like to know her z-score. So right away I notice 57.16 is not one of the labeled values from my empirical rule. So instead I should use the z-score formula. So let's set it up. Z is equal to the observed x value minus the mean of the sample divided by the standard deviation. I already know that the mean is 63.49 and the standard deviation is 4.34. And we are given another piece of information. We're given that this particular woman is 57.16 inches tall. This is the observed X value that I actually have. So we can just plug this information in and solve for Z. 57.16 is my observed X value. I'm going to subtract that from the mean and divide by the standard deviation to find my Z. Once I compute this, I find that Z is equal to the negative 1.458, so on. I'm just going to round this to 2 decimal places. Negative 1.46 is this woman's Z-score. So let's quickly relate this to the empirical rule. If the woman was 57.16 inches tall and her Z-score is a negative 1.46, remember that we use Z-score as a way to describe the distance of the data point from the mean of the distribution. So again, that Z-score of negative 1.46 tells me that this woman is negative 1.46 standard deviations from the mean. So she's somewhere, her height is somewhere here, which indeed it actually is. If she's 57.16 inches tall, if she's right about here, falling somewhere in between 54.81 and 59.15, we indeed see that she is negative 1.46 standard deviations from the mean. Now, I knew that I should go to the left because it was a negative. If it's a negative, that would imply that she is shorter than the average woman, right? She is shorter than 63.49 inches. Let's do another example. This woman is 72.12 inches tall. What's her Z-score? We're going to use the same formula using this same information for mean and standard deviation, but now our observed X value is 72.17. I'm just going to plug in 72.17 for my X. And this gives me a Z-score of 1.988. And again, I want to round this to 2 decimal places to 1.99. So she is almost 2 standard deviations above the mean because this is a positive 1.99. So she is taller than the average woman by almost an entire 2 standard deviations. Let's check that out with our picture and see if that matches up. 72.12 is almost 72.17. She is 1.99 standard deviations from the mean. Almost 2 full standard deviations from the mean. Let's do the last example. In this problem, I'm given that the woman's Z-score is 1.48, but I actually don't know how tall she is. I don't know what X is, and I have to solve for it. Whereas in the other problems, I was given X, and I just had to solve for Z. So let's try this scenario. We're going to plug in 1.48 as our Z because that's the given Z-score we have. We already have our mean as 63.49 and our same standard deviation as 4.34. So using our Z-score formula, I just want to plug all of the information in, keeping in mind that X is what I don't know and what I'm solving for. So 1.48 equals X minus 63.49 divided by 4.34. If you're watching this, you have some background in algebra. So we're going to first get rid of our denominator by multiplying both sides by 4.34, which gives us a 6.4232. And then I want to isolate X, so I'm going to add 63.49 on both sides. And that leaves us with 69.9132 is equal to X. And again, I'll apply the fact that I've been rounding to 2 decimal places to my final answer. And finally say that the woman is 69.91 inches tall. So thanks guys for watching my video. That's all I have for today. While my channel is still small, I am happy to take questions in the comments. If you have a particular homework question in your statistics course that you're working on that you would like me to review or make a video tutorial on, just drop it in the comments below and I will try to make a video tutorial on it as soon as I can. Thanks for supporting my channel. If you found this video helpful, I'd really appreciate a thumbs up. And thanks for watching, guys. Bye.